Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to study combination of resistors, that is series combination and parallel combination. Individual resistors can be connected together in series or in parallel combination, or in both series as well as parallel combination. For example, friends, suppose this is one resistor, this is another resistor. If these resistors are connected in this way, that means the one terminal of resistor is connected to the another terminal of resistors and a common current passes through these resistors, then these resistors are said to be in series combination. And if in this way the one terminals are connected to the another terminal of resistors and second is also connected to the second terminals, and in this way they are known as a parallel combination. So this is a series combination, this is a parallel combination. This series and parallel combination produce a complex network. The resistors are connected in series or in parallel combination. This is the parallel combination. One more resistor connected in series combination, one more in parallel combination, etc. etc. So when these resistors are connected in series and parallel combination, a complex resistor network is produced, or complex resistor circuit is produced. But advantage of this circuit is that we can generate or we can produce a resistance of different resistance value. Means suppose in circuit we require 22 ohm resistor. The resistance value of that resistor may be 22 ohm. But friends, the 22 ohm resistor is not available in market. So 10 ohm resistor, suppose this resistor having resistance value 10 ohm and this resistor having resistance value 12 ohm. When these resistors are connected in series, the 10 plus 12, that resistor network produce a 22 ohm resistance value. Similarly, when they are connected in shunt, the one more resistance value is generated or that is produced. So by using this circuit, by using this combination, that is series and parallel combination, we can produce a required resistance value. Now friends, in this lecture, in this topic, we are going to study the series combination of resistor. In series combination, the resistors are said to be in series when they are connected in a single line. What is a series combination? When the resistors are connected in single line. Suppose this is one resistor, this is another resistor. These resistors are connected in such a way that there is a single line. So these resistors are said to be in series combination. Friends, in series combination, the current flowing through resistors is same. That means the current flowing through first resistor, the amount of current flowing through first resistor is the same, that is the amount of current flowing to the second resistor. And the next one, suppose there are three resistors, first resistor, second resistor and one more resistor, then the current flowing through all these resistors is same. That means we can conclude that in series combination, a common current flows through all resistors, and that current get only a single path. There is only a single path, and through that path the current conduction takes place. Now the diagram of series combination, how the resistors are connected in series, that circuit diagram is going to display on your screen. In this diagram, the three resistors are connected in series. R1, R2 and R3. R1, R2 and R3 are connected to each other. Power supply having potential V is connected to this circuit. So in this circuit, the three resistors R1, R2, R3 respectively are connected in the circuit. Then a battery or a power supply having a potential V is connected to the circuit. Now the total resistance of this circuit is considered as RT. R1, R2 and R3, three resistors. Then the total resistance of these three resistors, this combination is RT. Let I means the current. Let I be the current flowing through the circuit. As the battery is connected, the current conduction takes place, and this current is considered as I, and this current flows through this resistor. When the current conduction takes place through the resistor, a potential drop is developed across each component, across each resistor. The potential drop across first resistor is VR1, V, that is potential, R1 suffix, that is a potential drop across R1, that is VR1, VR2 and VR3 with the potential developed across resistors R1, R2 and R3 respectively. The voltage drop across each resistor is given by using Ohm's law. Simple. What is Ohm's law? So long as the physical state of conductor remain constant, the current flowing through conductor is proportional to the applied potential. So V is proportional to I, or I is proportional to V, or V is equal to IR. So that V is equal to IR, this formula is used to find out the potential drop across each resistor. So obviously VR1 is equal to IR1. I, that is a common current flows through resistors R1, R2, R3. So VR1 is equal to IR1. Next VR2 is equal to IR2. Next VR3, that is a potential drop across resistor R3, that is VR3 is equal to IR3. And obviously VRT, that is a potential drop across total resistor. Sorry. The potential drop across total resistance, that is VRT, is equal to IRT. RT, that is a total resistance. So all these equations, that is VR1, VR2, VR3 and VRT, are considered as equation number 1. So what is your equation number 1? VR1 is equal to IR1, VR2 is equal to IR2, VR3 is equal to IR3 and VRT is equal to IRT. Friends, as this circuit is a closed loop circuit, it is a closed loop circuit. So obviously we can apply a Kirchhoff's voltage law. What is Kirchhoff's voltage law? The sum of the applied potential is always equal to the potential developed across each component. So in this case, VRT is equal to, VRT means a potential drop across that combination, VRT is equal to VR1 plus VR2 plus VR3. VRT is equal to VR1 plus VR2 plus VR3, that is equation number 2, and obviously it is Kirchhoff's voltage law. By substituting the values of VR1, VR2, VR3 and VRT, VR1, VR2, VR3 and VRT in the equation number 2, we get IRT. What is VRT? That is I into RT. VR1, that is I into R1, I into R2 and I into R3 respectively. That is VR1, VR2 and VR3. So by substituting this value in the above equation, equation number 2, we get IRT is equal to IR1 plus IR2 plus IR3. So obviously in this case I is a common. So by taking it out, IRT is equal to I in bracket R1 plus R2 plus R3. As I is constant, the current is a common that flows through all the resistors. That means the current flowing through R1 and current flowing through R3 is the same current. The same amount of current passes through R1, R2, R3 respectively. So that I gets cancelled. So RT is equal to R1 plus R2 plus R3. So what is total resistance of this combination? That is RT. So total resistance is summation of R1, R2 and R3. That is series combination. Suppose in circuit the n number of resistors are connected. In the given circuit the 3 resistors are connected. But suppose there are n number of resistors, that is R1, R2, R3 ... Rn, then the total resistance, that is RT, is given by R1 plus R2 plus R3 plus ... obviously Rn. So RT is equal to R1 plus R2 plus R3 plus ... Rn. So that is a series combination of resistors. So obviously from this we can conclude that The series combination of resistors is used to increase the resistance value. मगाशी आपण एक्झाम्पल घेतलं होतं 10 ohm आणि 12 ohm. 10 ohm resistor, 12 ohm resistor. When they are connected in series, 10 plus 12, we are getting 22 ohm. That means the series combination is used to increase the value of resistance. That is series combination. In next video lecture, we are going to study the parallel combination, how it affects the resistance value. So friends, keep watching our video lecture. Bye, take care, and we will see you again in a next lecture in which we are going to study parallel combination of resistor. So bye, take care, see you again.